Hello and welcome to the paper of Andhra Pradesh State of Higher Education. This is 2025 paper. In this paper, we will going to solve the questions of electronics and communication. So we are here to ECE ECE 2025. Now, what is our agenda? Agenda is this, that we will solve question one by one and see how we can answer question correctly. Cascaded of three amplifiers has individual gain of 25, 10 and 4. So you are having three amplifiers. You are having three cascaded amplifiers. So this is amplifier number 1, this is amplifier number 2 and this is amplifier number 3. We are having three amplifiers. Now what this amplifier is saying, this value is 25, means if this is my input Vi, this value is 25. What is the second value? Second cascaded is by 10, means whatever input to the signal is magnified by 10 volt, and third is what? Third is 4. So this is 4 and this is V out. Correct? Now they are asking about overall gain. What is the overall gain? So can I say if this is 25, so what is signal here? Signal here is 25 into Vi. What is output? Output is input multiplied by gain. What is output here? So you can say here input is 25 Vi. So 25 Vi into 10 is output. So 250 times of Vi is the output. And if 250 Vi is the input to the third, what is output? Output of the third situation will be 250 into 4, 1000 times of Vi. So can I say V out for the system is given by 1000 times of Vi. And if I want to write the gain of the system is Vo divided by Vi. This is closed loop gain, and closed loop gain is given by 1000. Now if I take, this is the normal value, but if you want to define the gain in dB, so always remember one thing, the 20 log of voltage ratio is known as dB. Always remember how you define the gain in dB. So it is 20 log of, and always remember this base is 10. 20 log of voltage ratio is known as gain. So 20 log of voltage ratio, 20 log of current ratio or 10 log of power ratio is gain. So when I take 20 log of this number, 20 log of base 10, 10 raised to the power 10 is equivalent to what? You can take 3 out. So if you take 3 out, this will be 60 into log 10 base 10. Always remember log 10 base 10 is 1. So this value is what? 60 dB. So if they have asked about normal value, the normal value is 1000, and if they are asking in dB, so you have to take care in which unit they are asking. So our answer for the question is 60 dB. I hope this is clear. A very fundamental basic question. Let's go to the next question. What next question is saying? Okay, what next question is saying? Next question is about the temperature coefficient of a material. So what is meaning of temperature coefficient of a material? always remember the temperature coefficient means what happens to the material if we increase the temperature of a material, means in case of disturbance. So always remember, when I say the temperature of a metal is increased, in metal you are having lot of free electrons. So if you increase the temperature, the vibration will increase. If vibration will increase, can I say one electron will face a lot of hurdles because of this vibration. So can I say for metal, and flow of electron is known as conductivity. So there is a resistance in the flow of electron, that is known as resistance. So can I say in metal, if you increase the temperature, resistance will decrease, resistance will increase. While in semiconductor, when you increase the temperature, the rise in temperature will breaks the covalent bond, and if it breaks the covalent bond, it will release one electrons and one holes. That is known as EHP pair. If it will release the EHP pair, the number of charge carrier in the material has been increased. If number of charge carrier in material is increased, then you are having more charge carriers in comparison to the previous case. So always remember, the resistance will decrease, number of charge carrier will increase, then resistance will decrease. So how you will write this? In metal, what we can say, in metal, if temperature is increased, resistance will also increase. Because of higher concentration of the electron will vibrate. If electron will vibrate, it will cause a resistance in the path of one moving electron. That's why it is known as resistance will increase. And if resistance is increased due to rise in temperature, we call this material as positive temperature coefficient material. What we call this material? Temperature coefficient material. I hope this is clear. If temperature is increased and resistance is decreased, and this is the case of semiconductor, because in semiconductor we are having covalent bond. So when you increase the temperature, covalent bond will break, and due to the bond break in covalent bond, the resistance will decrease. And this type of materials are known as negative temperature coefficient material. So always remember which material is positive temperature coefficient material? Metal. And second one is what? The second one is semiconductor, and semiconductors are negative temperature coefficient material. Semiconductors are negative temperature coefficient material. I am writing semiconductor by SC. How many semiconductors you are aware of? So fourth group of the periodic tables are semiconductor, in which you are having most popular silicon and germanium, atomic number 14, atomic number 32, and having 2, 8, 4. 4 electrons in outermost cell. Here also 2, 8, 18 and 4. 4 electrons in outermost cell. These are two semiconductor materials. I hope this is clear. So which option is correct here? The temperature coefficient of a metal is positive, while the temperature coefficient of a semiconductor is negative. Now you know the definition. Okay, next question is given for a transistor. If alpha of the transistor is equivalent to 0.98, what do we understand by alpha of the transistor? Alpha of a transistor is known as common base current gain. Common base current gain. For a bipolar junction transistor, alpha, when you make base terminal common between input and output, means you are applying input at emitter terminal and you are taking output from collector terminal. That arrangement is known as common base, and this is given by IC divided by IE. This is given by alpha is given by IC divided by IE. That is we know from this common base theory. Now what else they are saying? If alpha equal to 0.98, alpha also represents the value of charge carriers which are reaching at the collector. Alpha equal to 0.98 and I equal to 2 milliampere. So what is the value of IC? So you can say 0.98 milliampere, 0.98 is equivalent to IC divided by how much? Point 0.98 into 2 milliampere, and this value will be 1.96 milliampere. So which option is correct here? We are having option 3 is correct here. Let's go to the next. What they are saying, the gain of amplifier with the positive feedback is given by which relation? Always remember, the positive feedback is responsible for what? Oscillations. These are non-linear circuits. So what is positive feedback circuit? This is A, this is VI, this is VO. Generally we see this type of system because we believe in our maximum systems comes in the category of linear system. But if this feedback is positive, the link between output and input is known as feedback. So can I say this feedback is positive feedback, and what is this value? If this is V out, if this is V out, this is V out into beta. If I call this value as VE, what is the value of VE? The value of VE is given by VI plus V out into beta. Now, what is output? Output can be written as V out equal to A times of VI plus V out into beta, and I can write V out, I can take common, so V out divided by V in ratio is what? A divided by 1 minus A beta. So they are asking what is the gain of the amplifier with the positive feedback. So always remember, this cannot be amplifier. The positive feedback circuits are generally non-linear. So which option is correct here? The correct option is A divided by 1 minus A beta is correct option for our question. Next, a junction capacitance of the PN junctions depends on, they are asking about junction capacitance. So always remember, junction capacitance of a junction is depends on epsilon of SI, permittivity of silicon, divided by the width of depletion layer. What this XWDEP represents? Width of depletion layer. And always remember, for a PN junction, the width of depletion layer is given by 2 epsilon of SI divided by Q. It is 1 by NA plus 1 by ND multiplied by V into VBI. Always remember, VBI is known as built-in potential, that is constant for a given material, only function of temperature. NA and ND are the doping concentrations, and V is the applied voltage. and generally this voltage is what? Reverse bias voltage. The capacitance will be effective only its value is less. Always remember the junction capacitance is always given in the farad per unit area, because original formula is epsilon naught A into D, A divided by the gap between two plates, but this is given as farad per centimeter square. Correct? Now you can say everything is constant in this expression except two things. And what are those two things? The first thing is applied voltage. What is the first thing? The first thing is applied voltage, so it is dependent on VR. And what is the second thing? The second thing is doping concentration. Na and Nd. So what they are saying, the junction capacitance is dependent on which quantity? So can I say junction capacitance is dependent on two quantity? Applied voltage only? Yes, it is dependent on the voltage. Barrier potential? No, it is dependent on the doping concentration in applied voltage, so no need to take this. This is correct option. And doping concentration only? Yes, doping concentration is correct answer, but only doping concentration is not correct answer. So I hope this is clear. Okay, next is related to the JFET, one outdated transistor, but let's say, what is JFET? Which type of device it is? So always remember, for a JFET, junction field effect transistor, ID is given by IDSS into 1 minus VGS minus VP whole square. When I write this expression, you can say this is the current source which is dependent on VGS voltage. So it is which the source? It is the voltage control source. Which voltage will control it? VGS voltage will control this JFET, junction field effect transistor. Compared to bipolar junction transistor, the JFET has, always remember, the bipolar junction transistor will only works if emitter based junction is the forward bias. So if input junction is forward bias, its input resistance is less. So all FET devices, all field effect devices, whether it is JFET or MOSFET, all field effect devices have high input resistance. All FET devices have high input impedance, but all are having low voltage gain. The voltage gain is the highest for what? BJT. So which option is correct here? The D option is correct here. Let's go to the next question. What this next question is saying? Next question is saying, in the transfer characteristics of N-channel MOSFET, the region VGS greater than 0. So always remember, you are having your MOSFET into two regions. The first region is what? This is, let's say, P substrate. Then we are having three terminal. This terminal is known as source, this terminal is known as gate, and this terminal is known as drain. What else we want to say? We are saying that this is our body terminal. Correct? So always remember, every voltage in the MOSFET is applied with respect to source only. correct? And source is short circuited with the body to remove the body effect. That is one of the shortcomings of the MOSFET. So if you, and there is, let's say there is channel here, a channel is available here. So this is N plus material, this is N plus material. So what I am having in the channel? N plus. So when I am saying that VGS is negative, whenever I am saying that VGS is negative, what it means to have negative VGS? So VGS is negative means this voltage is negative, let's say. If this voltage is negative, which type of charge carrier you expect here? So negative charge is here. If this is negative charge and this is our dielectric, so one positive charge will induce across this. So initial value, you are having initial charge carrier as electron, and now you are having positive charge carrier here. So can I say when VGS is negative, you are depleting the channel. Means number of charge carriers in the channel will be less when you apply a negative voltage across VGS. So this mode of operation is known as depletion mode of operation. And if I select VGS greater than 0, the alternate case, when I take the VGS greater than 0, if I select the VGS greater than 0, which type of charge carrier I will apply here? Positive. In second case, you are having VGS positive. So what type of charge carrier you will attract here? Negative. So initial charge carrier is also negative, and you are attracting more negative charge carriers. So in this case, the channel will enhance, and this is known as enhancement mode. This mode of operation is known as enhancement mode. So you can say there are two operations. First operation is depletion mode, and second operation is what? Second operation is enhancement mode. Correct? So they are asking for VGS greater than 0, and VGS greater than 0, our transistor will work in which mode? Enhancement mode. I hope this is clear. Next question is the main advantage of using crystal oscillator. Always remember, the crystal oscillator means when you talk about other oscillators, sinusoidal oscillator, let's say Wien bridge oscillator, let's talk, you say about Wien bridge oscillator, or second oscillator is RC phase shift oscillator. In this oscillator, the oscillation is dependent on, in this oscillators, oscillation is dependent on what? Device parameter. Let's say oscillatory function is a function or gain of, means if you want to have oscillation, you have to maintain two criteria. This is known as Bark-Hussein criteria, A beta equal to 1 and angle of A beta equal to multiple of 2 pi. So I am writing 2n pi, and this criteria is Bark-Hussein rule, correct? So what we want to say, that this gain is dependent on the device parameter. Let's say transconductance it is dependent on, or it is dependent on lot of assumption. While that's why the gain is that's why the oscillations are not stable. But when we talk about the crystal oscillator, it gives you stable frequency or constant frequency oscillation. Here the frequency will change due to this change in the gain, because gain is a one sensitive parameter which is dependent on device parameter also. Okay, the cutoff frequency for n cascaded stages. So always remember, If they are asking about higher cutoff frequency, the higher cutoff frequency will be this. If they are asking the higher cutoff frequency of a transistor, higher cutoff, this value will be f1 into 2 to the power 1 by n minus 1. And if they are talking about lower cutoff frequency, then it is f1 divided by minus 1. So which option is correct here? They are talking about the lower cutoff frequency. So it is divided. Higher cutoff frequency will increase, lower cutoff frequency will decrease. Let's go to the next. A fixed bias circuit. Which type of circuits are fixed bias circuit? Always remember when we are having this circuit. Fixed bias circuit, biasing is done in the transistor from the DC to maintain a certain DC level in the transistor to have, so that it can entertain the AC signals. This type of circuit is known as this is RB and RC. Let me draw it correctly. RB and RC. So why we do biasing? The biasing is done to maintain this Q point. What is Q point? Q point is what? Maintaining the value of VCE and IC. Which potential is VCE? Always remember this current is IC and this potential is known as VCE. Always remember this. What is the stability factor? Stability factor of a transistor is given by the change in collector current due to the change in minority current. This is known as stability factor. This is known as stability factor. And what we want to say, for a fixed bias circuit, this is the fixed bias circuit, and for the fixed bias circuit, when you calculate this value will be what? This value will be beta plus 1. Always remember this. So 1 plus beta is correct answer. A very stability factor is high means this stability factor is measured that how circuit will your biasing is affected by the change in DC voltage, and it is highly sensitive circuit to the DC. That's why we don't select this type of biasing scheme. Let's go to the next. Commonly used bias in BJT circuit is, okay, so always remember the commonly used bias in the BJT circuit is always given by this, known as self bias circuit or voltage divider biasing scheme. This is VCC, this is one transistor, R1, this is R2, this is RC. This type of these are biasing schemes. Biasings are done in the transistor to maintain certain DC levels. So which scheme is more less sensitive to the change in device parameter or device parameters? That is self bias scheme. So which this is self bias or also known as voltage divider bias scheme. Always remember, we want to make our biasing scheme free from these parameters, alpha and beta, and transconductance. We want to make our biasing independent to all these parameters. because these parameters are highly temperature sensitive. If some parameter is highly temperature sensitive, this means if temperature will vary due to the reverse bias or anything, this circuit, the biasing point will change. If biasing point will change, the amplifier's gain and everything will change. So always remember this. This is a good biasing scheme. Preferable means there are two biasing schemes which are very useful. First one is current mirror biasing scheme, that is used for integrated circuit, and second one for discrete circuit we use this biasing scheme. Next question is whenever you are having combination of capacitor and diode, this forms two types of circuit. Always remember, let me write the note. Combination of diode and capacitor forms two circuits, and what those two circuits? Those two circuits are all known as clamper circuit and second circuit. First is clamper circuit and second circuit is known as peak detector circuit. The second circuit is known as peak detector circuit. So you are having two types of circuit, peak detector circuit and clamper circuit. Always remember, clamper circuit, always remember it, if output is taken across diode, which type of circuit, when you call this circuit as a clamper circuit, when you take output across diode output will known as clamper circuit, and when you take output across a capacitor, it is known as peak detector circuit. When you take output across capacitor, this circuit is known as peak detector circuit. Always remember this point. So here you are taking output across what? Diode. Now if you are having diode in upward direction, this is the diode, then it is known as positive clamper. This is known as positive clamper. And when you are having the diode in downward direction, you can call this as a negative clamper. Correct? So from the circuit, if you are taking output across a diode and RC combination, capacitor and diode combination is there, then we can say this is one clamper circuit. And what is the direction of this diode? The direction of the arrow is on the upward direction, so you can call this circuit as what? Positive clamper. One more thing, what is meaning of clamper that we should understand? If suppose I have this kind of circuit and I am calling this circuit as a clamper, clamping means to shift the voltage, and if my input is 2 sine of theta, then what can I say? I can have two types of output. Either I can have one output 2 plus 2 sine theta, and the another output I can have minus 2 plus 2 sine theta. So if I am having the first output, then I can say this is what? This is a positive clamper. And if I am having this DC as negative, then it is negative clamper. And who is responsible for storing this energy? The capacitor is responsible for storing this energy. I hope this is clear. So this is positive clamper circuit. Let's go to the next. Okay, in this circuit they are saying that amplifier noise figure is 3 dB and available power gain is 20 dB, and mixer circuit having noise margin of 10 dB. The overall noise margin, okay. Question is not given very clearly. Okay, so amplifier having noise figure of 3 dB, power gain of 20 dB, and mixer circuit having noise figure of 10 dB. So overall noise figure is given by what? 10 plus 20, 30, 33. Noise figure. This value will be what? Okay. The total phase shift in the phase shift oscillator. Always remember, to sustain the oscillation, how much phase shift is required? So always remember, if a circuit want to sustain the oscillation, it should satisfy the Bar-Coussin criteria. And what is Bar-Coussin rule? Bar-Coussin rule says that for a positive feedback system, the angle of A beta equal to 2n pi and magnitude of A beta must be 1. And n can be any integer. So what are the possible angles? 0, plus minus 2 pi, plus minus 4 pi. These are your choices. Now 0 is not in the choice, so plus minus 360 degree is also okay. So for any oscillation, this much of phase shift is required. But remember one thing, RC phase shift oscillator, total phase shift in the loop phase shift oscillator. So one of the phase shift oscillator is RC phase shift oscillator, which is given by this. This A represents amplification section. This is known as feedback network. This is known as feedback. And this portion is known as amplifier. So always remember, in the RC phase shift oscillator, this feedback provides a phase shift of 180 degree. The 180 degree phase shift is provided by this RC3 RC combination. So can I say remaining 180 degree phase shift should be provided by this? So can I say, for if you want 180 degree phase shift, so what amplifier you can use? You can use common emitter amplifier or common source amplifier or inverting op-amp. Inverting op-amp you have to use. So I hope this is clear. What are the choice for amplifier? The choice for amplifier is common emitter, common source or inverting amplifier. All three falls in the same category. All three are inverting amplifier, and the gain, the phase shift will be what? Integer multiple of 2 pi. So this is the criteria for any oscillation. For all oscillators it is correct. Now we are having next question, and what next question is saying? Next question is saying that in the network diagram, at t equal to 0, what is the value of di divided by dt? Okay, in this circuit, what are the circuit we are having? Let me redraw the circuit because question is not very clearly visible. This is your circuit, or this is your circuit. This is your circuit. What they are saying, that what is the value of di divided by dt plus? They are saying the what is value of di divided by dt at t equal to 0 plus. Okay, how to calculate this? Can you tell me what is the value, what is the energy storing element we are having? We are having capacitor as energy storing element. As we know, the capacitor stores the energy in form of voltage. If it stores the energy form of voltage, so can I say at T0 minus what is the total stored voltage inside the circuit? So you can say that at T0 minus, this capacitor is not connected to the source. If capacitor is not connected to the source, it will store the zero voltage. So you can say Vc0 minus equal to 0. And as you know that for a capacitor, Vc0 minus and Vc0 plus is same, because voltage across capacitor cannot change abruptly. So this will be what? Vc0 plus. Now we are interested, so Vc0 minus equal to Vc0 plus means if I draw my circuit at t equal to 0 plus, how circuit will looks like? The circuit will looks like this. This is 10 volt. This is one resistance of 1 kilo ohm, and here we are having capacitor. But how capacitor will behave? The capacitor will behave as a short circuit. So I am using one short circuit here. And can I say the current at I0 plus is equivalent to what? Potential difference divided by resistance. How much potential difference you are having? 10 volt potential difference you are having in 1 kilo ohm. So this is 10 milliampere is the value of current we are having. But I am not interested in, we are not interested in the 1 milliampere, we are interested in the di by dt. So when you draw the circuit for t greater than or equal to t greater than 0, can I say the circuit will looks like this? A 10 volt, then 1 kilo, then you are having what? 1 microfarad. And if I write the KCL, what is KCL? KCL across this is what? KCL across this is minus 2 plus 10 minus I minus, or let me write 1000 of I 1 by C integration of I dt equal to 0. What we are writing? We are writing one Kirchhoff's voltage law. But this is intro differential equation, so let's differentiate it. So this is I can say 100,000 di divided by dt equal to I divided by C. Do you know that this differential equation, the solution of differential equation is always valid for t greater than or equal to 0. If this solution is valid for t greater than or equal to 0, I can say that this everything is valid for t greater than or equal to 0. So I0 plus divided by dt is given by I. What is I at 0 plus? 10 milliampere. Divided by C. What is value of C? The value of C is 1 microfarad. 1 into 10 raised to the power minus 6. Divided by how much? 1000. So this is 10 raised to the power minus 3 cancel. This is 10 ampere per second. Why it is ampere per second? Because the unit of I is ampere and unit of t is what? Second. So 10 ampere per second is correct option here. It's not 100, it's a 10 ampere per second. I hope this is clear. Okay. Next circuit is dependent on, next circuit is what? RLC circuit shown below, the RMS voltage across the capacitor. They are asking the voltage across capacitor. Fine. Do you think that XL and XC are equal in this circuit? XL is equivalent to XC. Whenever you are having XL or is equivalent to XC, or whenever the power factor of RLC circuit is equivalent to 1, we can say, or whenever the input voltage and input current of RLC circuit are in phase, then we can say this is in resonance. So in resonance, can I say the current in the circuit, IRMS current is given by what? Applied voltage divided by resistance, which is 10 ohm. So this value is what? 20 ampere. IRMS is 20 ampere. Now do you know that what is voltage across the capacitor? The voltage across the capacitor is always given by VC, and what is VC? Minus J times of XC. This is the resistance offered by the capacitor at given frequency multiplied by the RMS current, which is 20 ampere. And what is value of XC? In our case, the XC is given by 20 ohm. So 20 into 20 is 400, and we are having the iota operator here. The iota operator contributes 1 in the magnitude and minus 90 degree in the phase. Always remember, 1 iota is responsible for 90 degree phase shift. And what is magnitude of the iota? Magnitude of the iota is 1. So if you are writing minus here, minus you can connect here. So what is the correct answer? 400 minus angle of minus 90 degree is correct answer for the question. If you have taken voltage across capacitor, this is 490 degree. Okay, next question is what? Next question is based on the Norton's theorem. And there is one change in this question. This resistance is not 4 by 5, this value is 1. Now, what is Norton's equivalent? As we know that the Norton's equivalent of a circuit is nothing but what is Norton's equivalent? Norton's equivalent is always given by a current source with equivalent resistance. That current source is known as short circuit current source or Norton's current source, and this is known as Norton's resistance. This is Norton's equivalent. Then what is the definition of IN and RN? Keep this thing in mind. IN is the current, the short circuit current when you apply a short circuit across the load terminal. Let's say this is our load terminal. And if I apply a short circuit here, this current is known as ISC or this current is known as IN. Correct? Okay, how to calculate this? Very simple. 1 and 2 in parallel. So 1 and 2 in parallel can be written as 1 into 2 divided by 1 plus 2 because both are connected in parallel. This is in series with 2. So total impedance is what? 2 plus 2 by 3. Two plus 2 by 3 is 6 plus 2, 8 by 3. You know what is the equivalent resistance till this point? 8 by 3. What is applied voltage? Applied voltage is 2. So what is current coming from the source? 2 divided by 8 by 3. So 6 divided by 8, or this is 3 divided by 4. So can I say the current coming from the source in this network is given by current coming from the source in this network. So current coming from the source is what? Current coming from the source is 3 by 4 ampere. If this current is coming from the source is 3 by 4 ampere, now we have to divide this current into two parts. So how much current? This is the current distribution, parallel current distribution, and the current distribution is given by what? If you are calculating ISC, you have to write 2 divided by 1 plus 2 into incoming current, which is 3 by 4. When you write this, 3 and 3 cancel, the value is what? Half ampere. So what is value of current? The current is equivalent to 1 by 2 ampere. If I take this as a 1. And what is value of Norton's resistance? So always remember, when you are having independent sources in the network, then resistance of a network is always independent to the supply. So you can say, if I replace my supply Rn calculation or equivalent resistance calculation, if I replace my voltage source, then I have to replace the voltage source by 0. If I replace it by 0, here you are having 2, here you are having 2, and series you are having 1. You have to calculate the resistance for which terminal? Across the load terminal. This is equivalent resistance, and same equivalent resistance is known as Norton's resistance. 2 and 2 in parallel will give you 1, and 1 with 2 parallel with 2. Why 2 parallel with 2? Because starting point and ending point of these two components are same. When you are having same starting and ending points for two component, it will give you a parallel effect. And plus we are having one component which is in series, so RTH equal to what? RTH or RN or R equivalent, all are same, and this value is what? 2 ohm. So what is correct answer? 2 ohm is correct answer, and answer for current is, if we take this value as 1, the answer for current is not 2 by 5, this answer is what? 3 by, this answer is 1 by 2 ampere. So keep this thing in mind. Okay, in next circuit, they are asking for the equivalent capacitance between terminal 1 and terminal 2. So always remember, we are having, what effect we are having in the capacitance? The effect of capacitance is opposite of what happens to the inductor and resistance. So whenever I say that capacitance C1 is parallel with C2, what it means? Its equivalent capacitance is given by C1 plus C2, that is opposite of resistance, because in resistance we define the equivalent capacitance by C1 C2 divided by C1 plus C2, and whenever I say C1 in series with C2, then what is equivalent capacitance? Equivalent capacitance is C1 C2 divided by C1 plus C2. Correct? So always remember this. Here we are having 1 microfarad and 1 microfarad, 1 microfarad and 1 microfarad capacitance in parallel. So this will gives you effect of 2 microfarad. 2 microfarad in parallel with 1 microfarad. So can I say, if I start from A and let's say I am drawing the lower branch, the lower branch is 2 microfarad in series with 1 microfarad. This is 2 microfarad, this is 1 microfarad. And on the top branch we are having what? 2 microfarad. Because both in parallel. Now you know that what is the equivalent of 2 microfarad and 1 microfarad. When I find the equivalent of this, what is the equivalent? Equivalent is given by 2 into 1 divided by 2 plus 1. That is 2 by 3 microfarad. If this is 2 by 3 microfarad, can I say 2 by 3 microfarad is in parallel with 2 microfarad? This is the equivalent, and can I say 6 plus 2, 8 by 3 microfarad is correct answer. What is 8 by 3? 8 by 3 is 2.66 something. So here which option is correct? Here D option is correct for the given question. A very simple circuit of equivalent resistance and capacitance. Now what is next question? Next question is related to the graph. Which one of the following represents the total number of trees? Always remember, the total number of trees is given by nodes plus branch minus 1. 1, 2, 3, 4, 5. 5 nodes, how many 5 branches, how many nodes? 4 nodes minus 1. How many trees you can have from here? 9 minus 1, 8. 8 is correct answer for the given question. This is question from graph theory. Correct. Let's go for the next. A lossless line will be distortionless. A lossless line will be distortionless if phase shift. Always remember, the phase shift is what? 2 pi by lambda. It is dependent on what? Frequency. Next question. Okay, the transmission line with the standing wave. The transmission line with the standing waves, distance between the voltage maximum and voltage minimum, always remember this distance is always lambda by 4. If this is the voltage maximum, you can have this times of current maximum. So this distance is what? Lambda by 4. Next question. Next question is related to the transmission line. In the ideal transmission line, the match load. If load is matched, then reflection coefficient is always equivalent to 0. Always remember, for a matched load, there is no reflection because the mismatching of the load is the only cause of the reflection. So reflection coefficient is 0. If reflection coefficient is 0, VSWR is equivalent to what? VSWR equal to 1. So which option is correct here? 1 and 0. They are asking about the VSWR, voltage standing wave ratio, and reflection coefficient, that is 1 and 0. A transmission line has VSWR equal to 2. The reflection coefficient, always remember, the reflection coefficient is given by VSWR plus 1 divided by VSWR minus 1. And that value is 2 minus 1 divided by 2 plus 1. This value is equivalent to 1 by 3. So which option is correct here? 1 by 3. A very basic formula based question. What is next? Next is the input impedance of a short circuit lossless line of the length less than the quarter wavelength. Means they are saying that for this condition, for which condition? When condition the length of the transmission line is less than lambda by 4 quarter wavelength, then what is the nature? The nature is always pure inductive. For length greater than lambda by 4, capacitive, and for lambda equal to L equal to lambda by 4, it is resistive. The TV channel bandwidth, always remember the TV channel bandwidth, it's a theoretical question. The bandwidth is 7 megahertz, 6.99 something, so 7 megahertz is correct. Next is broadcast television, the number of scanning per frame is chosen to be odd number. We have seen this in our television syllabus, that we want to make interlacing easier. The full scale deflection current of a multimeter is, the full scale deflection current of a multimeter is 50 microampere. The sensitivity, always remember the sensitivity is given by 1 divided by full scale reading. So 1 divided by 50 microampere, so you can write 10 raised to the power 6, and if this is 10 raised to the power 6, 1000 into 10 raised to the power 3 divided by 50, this is 20 kilo ohm per ampere. This is the sensitivity we are having, kilo ohms per volt, kilo ohms per volt. Next, what is the bandwidth of the CRO supplied? Okay, the horizontal plates of the CRO is supplied with the following. Okay, horizontal plate of the CRO is always sawtooth waveform. We have seen this in CRO measurement. The resistance can be measured. Okay, resistance you can measure with the help of what? With the help of ohm meter or with the help of bridges, because ohm meter is the device from which you can measure the resistance, and there are some techniques to measure the resistance. One of them is Wheatstone bridge. Wheatstone bridge. And what is Wheatstone bridge? The Wheatstone bridge is this. So when the condition is balanced, when bridge is balanced, you can say this is R1, this is R2, this is R3, this is R4. So, and we call this unknown load. So to calculate the unknown load, we try to balance these 2 points. What is the balanced bridge condition? When Vx equal to Vy, if we achieve this condition, then we can know the value of Rx. So this is one of the technique to calculate the resistance. So resistance and bridges are correct option to calculate the resistance. What is next? The Q meter. The Q meter is what? Q meter is used for the quality factor of inductor and capacitor, as it is clear from the name. Which of the following is a temperature measurement element? Always remember the thermocouple is what? Temperature measurement element. What is the function of a signal generator? Signal generator, there are 2 types of instrument available in the laboratory. The first one is CRO and second one is known as function generator. Or also known as function generator, or also known as signal generator. So signal generator is used to generate the waveform for your testing. Which type of waveform? Either you can have sinusoidal waveform, or you can have square waveform, you can have sawtooth waveform. All types of waveforms are available in the function generator. So function generator or signal generator. So why we use this? To generate the electrical signals. Which of the following cannot be used to produce the square waveform? Always remember, these oscillators are the Wien bridge oscillator, T oscillator and Hartley oscillator. These are sinusoidal oscillator. Only a stable multivibrator. Which multivibrator? A stable multivibrator can act as an oscillator, and that is square wave oscillator. A stable multivibrator. Always remember, in stable multivibrators, both the outputs of the multivibrators are always saturated outputs. Which type of outputs we are having? Saturated outputs. Which of the following signals are generally Wien bridge oscillator? Okay, we have seen in the last slide the Wien bridge oscillator. What is Wien bridge oscillator? You can say this is the diagram of Wien bridge oscillator. If I want to draw the diagram of Wien bridge oscillator, it looks like this. Correct? And here we are having one RC pair here, and one RC pair here. This oscillator is known as Venn bridge oscillator. Which oscillator? Venn bridge oscillator. It produces which waveform? Sinusoidal signal at output. The characteristic, the next question is related to the control system, and what this question is saying? This question is saying that the characteristic equation of a control system is given by this. So you have to remember that characteristic equation of a control system is S square plus 2 zeta omega n into S plus omega n square equal to 0. This is known as characteristic equation, standard characteristic equation of a control system, prototype. Now you can compare with this S square plus 2 zeta omega n S square plus, okay, what is the value of omega n? So you can say omega n square equal to 16, so omega equal to 4 radian per second, and zeta equal to what? So 2 zeta into 4, 2 zeta into omega n is given as 4, equal to what? 4. So what is value of zeta? Zeta is equivalent to 1 by 2. What zeta represents? Zeta represents one underdamped system, correct? Now we are interested in what? Now we are interested in calculating which? Resonant frequency. Always remember, there is one frequency which is known as damping frequency. Damping frequency is time domain response of the control system, while this is the steady state response of the control system. When your input is a sinusoidal input, then we calculate the resonant frequency. So you can say the resonant frequency omega r is omega n 1 minus 2 zeta square. Always remember, this is resonance frequency. This is the steady state analysis of the control system. Steady state analysis, or you can say this is the analysis when your input is a sinusoidal input. So what is omega n? Omega n is 4, and this is 1 minus 2 into how much? 1 by 2 square is 1 by 4. This value is 2. 2 minus 1. So this is 4 by under root of 2. 4 by under root of 2 can be written as 4 under root of 2 divided by 2. So what is correct answer? 2 under root 2 is correct answer. So this is correct answer. Always remember, resonant frequency and damping frequency are two different things. Don't calculate the damping frequency. What is damping frequency? The damping frequency is given by omega d equal to omega n 1 minus zeta square. This expression is valid for zeta greater than 0 and less than 1. But remember, the validity of this expression is only zeta greater than 0 and less than or equal to 1 by root 2. 1 by root 2 is 0.707 and 1 by 2 is 0.5. So it is valid in this range only. This is steady state response of the system, and first one is what? First one is time response of the control system. This variable is from time response of the control system. This variable comes from time response of the control system. Next, natural frequency of a unity feedback control system. Okay, they are saying that this is one unity feedback control system. So natural frequency always comes from what? Natural frequency comes from the characteristic equation. So they are saying that the value of G is, the value of G is given by what? The value of G is given by 10 divided by S into S plus 1. And they are saying that the natural frequency for the unity feedback and value of H is given as 1. So 1 plus GH is what? Characteristic equation. Characteristic equation. This is not common emitter, characteristic equation. So 1 plus 10 divided by S square plus S equal to 0. Or you can say S square plus S plus 10 equal to 0. This is the characteristic equation. If characteristic equation is given, we can find the we can compare it with the standard equation s square plus 2 zeta omega n s plus omega n square. So you can say what is value of omega n square? The value of omega n square here is 10. So omega n equal to what? Under root of 10. Under root of 10 is what? 3.14 something. 3.16 is correct option for the given question. So previous question was the steady state analysis of the control system, and this question is dependent on the time response of the control system. Next, the phenomenon of injection luminance is the basis principle of working. This is always the principle of working for LED. Next, which of the following statement with respect to solar cell? Okay, with respect to solar cell, which of the statements are correct? Solar cell is a large PN junction. Yes. Generally, which diode is used? PIN diode is used. In a solar cell, PN junction is near to the surface. Of course, that's why we are having excitement in the charge, excitation in the charge carriers. Solar cell is a photovoltaic cell. Correct. First, second, third option. Which of the all are correct? Which of the following is an active transducer? Always remember thermocouple. A temperature measurement is active transducer. Next, what type of transducer is used to convert force into electrical signal? That is load cell. Is kind of transmit. Two transistor model of SCR consists of two following transistor. So we should have both transistor different. If one is NP and another is what? PNP. Next, the turn off an SCR is necessary to reduce the current less than the holding current of the SCR. The parallel inverter. Okay, theoretical. The working of SMPS is based on what? Chopper principle. Next question is from communication. A 100 kilohertz carrier is simultaneously modulated by 300 hertz and 2 kilohertz audio signals. So two audio signals are given. One carrier is given. So let's say carrier is having frequency. Carrier is having frequency FC equal to how much? 100,000 kilohertz. Correct? And you are having two modulated signals. So this is F1, I am calling. These are modulating signal, not modulated signal. So this is 0.3 kilohertz and F2 is equivalent to 2 kilohertz. What do you understand by modulation? So what is the easiest definition of modulation that you should apply here? Modulation is what? Modulation, the output of a modulator is always multiplication of baseband signal MT into carrier signal. And when you multiply two signals, sinusoidal signals, once you add the frequency and you subtract the frequency. So here frequency is what? 100 kilohertz. And you are multiplying this by two frequency component. One is 3 kilohertz and another is 2 kilohertz. And another is 0.3 kilohertz. So when you multiply this signal, how many frequency component is available at output? So frequency component available at output is 1000 plus minus of 2, and this is 1000. Means once you add the component and once you subtract the component. So this is 1000 plus minus 0.3. So this is 1002,998, 1000.3 and 999.7. These are four components available. So 1003 is available, this is available, this is available. What is not available? 700 kilohertz is the frequency which is not available at the output. Whenever you multiply two signals, always remember you have to add the frequency and you have to subtract the frequency. You don't need to apply any formula in doing that. An AM wave is given by this. Okay, when you look at this, this is the standard equation for the amplitude modulated wave. What is the standard equation? CT, or let me write XT. XT is what? Amplitude modulated signal. And amplitude modulated signal is given by AC 1 plus mu1 mu into cos of omega mt multiplied by cos of omega ct. Correct? This is amplitude modulated signal. This is which signal? This is one AM signal. Now, what is given? It is given that it is not a single frequency. It is given that the message signal is having two frequency. If message signal is having two frequency, then I can write this is multi-tone modulation. This is single tone. What we can call this modulation? This modulation is single tone. While this modulation is known as multi-tone. Multi-tone or double tone modulation. And what they are asking? They are asking for modulation index. So here modulation index is this, and always remember for distortion free communication, the value of the modulation index should be less than 1. And for ideal analog communication, this waveform, amplitude modulation, the modulation index lies between 0 to 0.7. It should be approximate 0.7. But what is the theoretical value? It is less than 1. So we can say the value of mu should be greater than 0 and less than or equal to 1. So you can say mu equal to what? Mu1 square, which is 0.4 square plus 0.3 square. Mu equal to 0.3 plus 0.4 square is 0.25. And when you take under root of 0.25, it is 0.5. So what is modulation index? 0.5 is modulation index. What is the range? Range is 0 to 1. Next, envelope detector. Okay, when you want to demodulate the signal, there are two processes. One type of detectors are known as synchronous detector. One types of detectors are known as synchronous detector. One type of detectors are known as synchronous detector. What is synchronous detector? That category of the detector in which the incoming signal, F incoming signal, and a local oscillator signal is having zero phase shift. These two frequencies are equal. When the frequency of the modulated signal and the frequency of local oscillator is same, then you can say this is one synchronous detector, and it creates the problem. This is the hypothetical concept. So that's why we are having Costas loop and everything, Poillet carrier, the concept of Poillet carrier. But in envelope detector is what? Envelope detector is asynchronous detector. Envelope detector is known as asynchronous detector. How it works? It works like this. So asynchronous detector means what? This is the kind of circuit. This is half wave rectifier kind of circuit. This value is, this is the circuit which is known as envelope detector circuit, generally used to modulate, demodulate one AM signal. If this is your AM signal, what you can expect here, you can expect here the envelope of that signal. And always remember, the message of the signal lies in the envelope only. The low frequency part means if I want to draw the output of a amplitude modulated signal, the output looks like this. This is your envelope. This outer boundary is known as envelope. And what is inside this? Inside this we are having one carrier wave. So which part is known as envelope? This part. This part is known as envelope. So whenever I am saying that there is something which is envelope detector, so envelope detector will separate this from the modulated signal. And what is inside it? Inside it is carrier. SSB can be obtained from the balanced modulator. What is balanced modulator? Balanced modulator is something which generates message into carrier product. Means you can say balanced modulator is DSB SC generator. Balanced modulator is DSB SC What is balanced modulator? Balanced modulator is DSB SC generator. So when you generate the DSB SC, you are having this kind of signal. Always remember, this is one DSB SC. You are having double sideband with no carrier. This frequency is FC, this frequency is FC plus FM, this frequency is FC minus FM. And always remember, all Fourier transform expressions are symmetrical. Fine. Now what I am saying that suppose we want to generate one SSB SC. So we will transmit only one sideband. So which type of filter I will use? If I use one high pass filter, which entertains the frequency only greater than FC, if I use one high pass filter, always remember this all expression, frequency domain expressions are symmetrical. So when you use the high pass filter, what kind of expression you are having? This kind of expression you are having. We are having this and we are having this. This is known as single sideband SSB. This is known as SSB SC transmission when upper sideband is transmitted. Which sideband is transmitted? In this question we are transmitting the upper sideband. And suppose I use a band pass filter. This is the filter number 1 we are having. What is the filter number 2? Suppose I use one band pass filter. If band pass filter is used, means I want to use one filter between FC minus FM to FC in this range. Then what will be your output? Your output for the circuit will be what? Your output for the circuit will be this. This you will get from the output. So suppose what is the meaning of the balance modulator? Always remember the balance modulator, the double balance modulator is always DSB SC generator. And if you will filter out the DSB SC, what you will have? You will have the SSB SC, and you can have both SSC SB for upper sideband transmission and SSB SC for lower sideband transmission. So what you should use? You should use one filter. Which of the following circuits indirect FM generator? Always remember Armstrong modulator. What is Armstrong modulator? It uses the concept of the frequency multiplication. Indirect generation means in Armstrong modulator, a narrowband FM signal is converted into wideband FM signal using frequency multipliers. Using the concept of frequency multipliers. Next, pre-emphasis circuit. Always remember this very periodic question in your exam. Many times they have asked this question, what is the pre-emphasis circuit? Pre-emphasis circuit is just a high pass filter kind of thing. This circuit is known as, this kind of circuit, a high pass filter kind of circuit is known as pre-emphasis circuit, and pre-emphasis circuit will boost the higher frequency component of FM signal. So can I say which one is correct answer? It will boost the higher frequency component, and this comes in the pair, so we use one more circuit, that is de-emphasis circuit, act as a low pass filter. Okay, what is next? The next is the commercial FM broadcasting, the maximum frequency deviation. Always remember, in the maximum frequency deviation for commercial FM broadcasting means they are talking about wideband FM. And always remember, in wideband FM, the frequency deviation is given by what? Plus minus of 75 kilohertz. It's a standard value. And you should know few more formula in the wideband FM. That is, one more is Carson's rule. For the bandwidth calculation. And bandwidth of FM, if someone asks what is the ideal bandwidth of FM, so always remember the ideal bandwidth of FM is ideal FM bandwidth is what? Ideal FM bandwidth is infinite. There is no doubt about it. But if you use Carson's approximation, the bandwidth is given by 2 times of delta F plus FM, or you can say this is 2 times of FM into beta plus 1. Beta is known as modulation index of the FM. Always remember, FM is what? FM is the frequency of the modulating signal. And what is delta F? Frequency deviation. Next question is, a super heterodyne receiver. A super heterodyne receiver works on the every modulation scheme. This is generally a frequency translator, because your components are not compatible with the high frequencies, so it translates those on the intermediate frequencies. So they are saying that incoming signal, you are having incoming signal of 1200 kilohertz, and intermediate frequency is equivalent to what? 450 kilohertz. This is the frequency of local oscillator, and this is 450 kilohertz. So what is image frequency? So you can say image frequency, image means what? Signal image. So image frequency is given by 1200, the incoming signal frequency, plus 2 times of f of IF, or 2 times of f of minus IF. So this is 2 into 450, which is 1200 plus 900, which is 2100. So which option is correct? 2100 is correct option. Next, for m greater than 4, the signal constellation of M Array PSK, always remember it is elliptical. Next, the Nyquist sampling rate for the signal band limited to 4 kilohertz. What is band limited to 4 kilohertz? Band limited to 4 kilohertz means the maximum frequency component available in the signal is known as 4 kilohertz. So what is sampling rate? So to reconstruct a band limited signal, sampling theorem is only applicable on the band limited signals only. To reconstruct a band limited signal, to reconstruct a band limited signal, the sampling frequency must be greater than or equal to twice of FM. So what is the minimum sampling frequency? The minimum sampling frequency or the theoretical limit is what? Fs minimum is equivalent to 2 times of FM. Which signal frequency I am considering is FM? Whatever is given. So 2 into 4 kilohertz is the minimum sampling frequency, and that value is 8 kilohertz. Here we can say which option is correct. 8 kilohertz is correct option. Okay, next. The modulation method that represents different bit as different phase shift. Always remember, BPSK or PSK is the method in which, suppose I want to represent logic 1. So logic 1 is represented by A cos of omega CT. And if I want to present logic 0, I will represent it by A cos of omega CT plus pi. So suppose you are having 2 bits you want to transmit. If you want to transmit 2 bits, you can have the phase shift of pi. If you want to transmit 4 bits, then it is phase shift of pi by 4. So when you are differentiating the bits with the logic of phase shift, it is known as PSK, phase shift keying. What is meaning of this? This is phase shift keying. This is phase shift keying. What is frequency shift keying? In frequency shift keying, you transmit logic 1 and logic 0 and you separate them by 2 different frequency. What is ASK? ASK is when you differentiate 1 and 0 by the amplitude. And what is MSK? MSK is the mix of ASK and PSK. This is the mix of ASK and PSK. This is known as MSK. I hope this is clear. Next, the data rate of the signal is 155 microseconds per micro per second. Bit time is okay. So what they are asking? They are asking what? They are asking the data rate. Okay. 1 divided by, data rate means what? The frequency. 1 divided by bit duration. 1 divided by 115 10 raised to the power 6 is the data rate. And this value is what? 10 raised to the power 5 divided by 115. Let me check. This value comes out to be 10,000 8695. Okay, which option is correct? This is the data rate 8696. I hope this is clear. Next, the spectral density of a white noise. Okay, what is the definition of white noise? You should understand. White noise is a hypothetical noise. Means the noise which attack which attacks every frequency component with same intensity a noise which attacks on every frequency component with the same intensity is known as white noise. So this is the power spectral density, and power spectral density of the white noise is what? This is having the flat spectrum, because it comes from the definition. Power spectral density is what? Distribution of power with respect to frequency, and we can say a white noise is having uniform distribution. So and height of power spectral density is n by 2. So what type of distribution we are having here? Uniform distribution we are having in this. Next, the long distance short wave radio broadcasting uses ionosphere. Theoretical question. Which of the following wave is not traveling? Always remember, when you select a different value of omega t, maybe this is traveling with the positive x direction, this is positive x direction, and what this wave is? This wave is standing wave. This is not traveling. A wave which is having this, if you mark a point on the wave and for this point will be replaced here to here, then you can say this wave, when you draw the locus, this wave is traveling. If it is not traveling, it is a standing wave. Let's go to the next. A reflex klystron oscillator. Always remember, there are two things. The one is two cavity klystron. And two cavity klystron, in which we are having two cavities which are known as buncher cavity and catcher cavity. This is microwave amplifier. This is known as microwave amplifier. And another thing we are having is reflex klystron. This is known as microwave oscillator. And this is only having the one cavity, which is known as buncher cavity, and in this we are having buncher cavity and catcher cavity both. So one cavity resonator, only we are having one cavity. And one more thing is magnetron, which is resonator. Waveguide may be considered as, okay, as you know that for a rectangular waveguide, the minimum cutoff wavelength is 2A. Maximum cutoff wavelength is 2A, means the frequency is given by C divided by 2A. And this is the minimum frequency that can be entertained by the waveguide. If this is the minimum frequency, means frequency is below than C by 2A, will generate zero output at another end of the waveguide. And it allows only signal which lies in this range. For this, output is finite. So if you are talking about something which do not entertain the low frequency signal, but it transfer the high frequency signal, this type of circuits are known as high pass filter. These are frequency selective network then. The maximum aperture of a lambda by 2, okay, this is theoretical again, 0.13 lambda square. Which of the following can be used as a radar? Okay, which of the following radar cannot be used as a range measurement? And that is continuous wave radar. The scope of radar in displays the target and target range alone. The fiber optic system and source detector, PN junction and photodiode. Always remember. The standard reference antenna for the directive gain. Always remember, there is one hypothetical antenna, and that antenna is known as isotropic antenna, which radiates equal in all direction. This is known as isotropic antenna or point radiator. So which radiate equal in all direction. Next, the dominant pole of rectangular waveguide. Always remember, the dominant pole in the rectangular waveguide is TE10. TE10 is known as dominant pole for rectangular waveguide, and for circular waveguide is this TM11 is the dominant pole, and this is the pole, this is the mode of the rectangular waveguide which is having minimum frequency and maximum wavelength mode. Minimum frequency and maximum wavelength mode is TE10. Next is, which system allows the entire bandwidth available? CDMA, carrier detection multiple access, allows you to access the entire bandwidth. Next, which type of gate this is shown? Can I say here value is A complement because it is NAND gate, here value is B complement, here value is A complement B whole complement, here value is A B, because what is the working of NAND gate? Whatever is input to the NAND gate, it will multiply them and will make it complement. Okay. So can I say, if I call this value as X, if I call this as value as Y, so final answer is X dot Y complement. And X dot Y complement can be written as X complement plus Y complement using De Morgan's law. So this is A complement B double complement plus AB complement double complement. You know that double complement of a number is a normal number. So this is A bar B plus AB bar. If A bar B plus AB bar is there, can I say this is nothing but A XOR of B? Which gate it is? XOR gate it is. Full adder can be implemented by what? How you can implement the full adder can be implemented? Always remember, there is thing which is known as multiplexer, which can implement any logic. Using multiplexer, any logic can be implemented, whether it is full adder, half adder, full adder, half adder, full subtractor, half subtractor, or any Boolean logic you can implement with the help of what? Multiplexer. Always remember. And the size of multiplexer can be vary. What is dual? If you convert plus by multiply, multiply by plus, this is the dual expression. So which one is dual expression? Very simple. NAND gate with the positive logic will operate as, okay, OR gate with the negative logic. Because what is NAND gate? If we are talking about NAND gate, if this is X, this is Y, what is output? X dot Y complement. And if I write one OR gate, the OR gate will looks like this. This bubbled OR gate, or you can say negative logic. So this can be X complement plus Y complement, and X complement plus Y complement can be written as X dot Y whole complement. So this is correct option. The noise margin, the main advantage of CMOS over TTL. Always remember, the CMOS circuit, complementary circuit, MOS circuit, this is PMOS, this is NMOS. So always remember, only one of the transistor is conducting at a given frame of time. If only one of the transistor is conducting, that makes current in other transistor equal to 0. So you are having, ideally, you are having what power dissipation equal to? Power dissipation is equivalent to 0. While this is not the case in case of BJT. That if not 0, if not power dissipation is not 0, then it is minimum. While the power dissipation, reduced power dissipation. But while in BJT you don't have this kind of luxury. So this is logic, CMOS logic family, and one more logic family is transistor logic family. Emitter coupled logic switching speed is very low. Always remember, from the logic family point of view, ECL is the fastest logic family. Fastest logic family. ECL is the fastest logic family, which and it is also known as non-saturated logic family. None of the transistor will enter into the saturation. Non-saturated logic. This is also known as non-saturated logic family. So if it is non-saturated logic family, then none of the transistor will enter into the saturation. So can I say the transistor are not saturated when conducting? This is correct reason. Minimum number of comparators. This a 6-bit A to D converter. This converter is known as fastest converter, which is also known as flash type of converter. What is name of this converter in which comparator is required? Flash type. And how many comparator requires? So number of it converts. What is conversion time? Conversion time in the flash type comparator is equivalent to 1 clock cycle. Only 1 clock cycle it will convert. And what they are saying that how many comparators are required? So number of comparator, it is 2 raised to the power n minus 1. So what is 2 raised to the power n? N is number of bits. So 2 raised to the power 6 minus 1, which is equivalent to 63. So how many comparators are required? 63 comparators are theoretically required for this. Figure of merit of the logic family is given by. Okay, figure of merit means suppose you want to compare two logic families, then on which parameter you will compare those two logics, and that is known as figure of merit. So can I say the figure of merit is just the product of this power dissipation into propagation delay. This product is known as figure of merit. So which propagation delay and power dissipation is we want minimum power dissipation and minimum propagation delay for a good logic family. This is the primary condition to achieve. A 10-bit ADC has a range of plus minus 5 volt. Then resolution. Okay, so can I say the resolution is given by full scale reading divided by number of steps, or number of steps can be represented by 2 raised to the power n minus 1. So what is full scale reading? You are having full scale reading 10 volt and how many bits? 10 bits. So 2 to the power 10 minus 1, which is approximately 1000. So 10 millivolt is correct option. 10 raised to the power 10, 2 raised to the power 10 is 1024 minus 1 is approximately 1000. So answer is what? 10 millivolt is correct answer. What is minimum number of JK flip-flop required to design a modulo 5 counter? Okay, you know that only one flip-flop can handle 1 bit. So suppose modulo 5 counter means 5 stages are there. It counts 5 states. Mod 5 counter means Mod 5 counter means it will count 5 states. But if you take, let's say, 2 bits, so 2 bits can count how many states? 2 bits can count 0 0 0 1 1 0 1 1. It can count only up to 4 states, so this cannot be mod 5 counter. So how many bits are required? 0 0 0 0 0 1 0 1 0 0 1 1 and 1 0 0. These are 5 states. So how many bits are required? Minimum 3 bits are required to calculate modulo 5 counter. Modulo 3 bits can go up to 7. 1 1 1 means it can count 8 states, but if we need mod 5 counter, you have to do this at least. Next, 1 megabyte is equivalent to theoretical. A microcontroller differs from a microprocessor on both the levels, on the chip memory and chip ports also. Okay, which of the following input methods does not use the CPU for performing input-output operation? DMA, direct memory access. Next, the program counter in the computer special purpose register will count to the next instruction to be fetched. So program counter will always represent next instruction to be fetched from the program. 8085 series has how many 16-bit register? 2. Next, okay, this is very simple addition. Move A means load the 9C data into A and add with 64H. You can add both. Okay. How many byte addressable memory is available? 32 bytes. On power of 8051 uses which ROM location for R0 to R7, 00 to 07. These are based on theory. Instruction at the end of interrupt service takes the execution back to the interrupted program. That is return instruction. Instruction that involves the various string manipulation operations are known as string instructions. Very basic. This comes from the definition of string instruction. Which of the following units of a periodic refreshing? Always remember, dynamic RAM needs a periodic refreshing. Firewall in the computer is used to protect the computer from unauthorized access. How many layers in the OSI model? 7 layers. How many bits are in the ether address? 48. What does router do in a network? Okay, router determines which packet will go to which layer. Which of the following is an operating system? Windows clearly is an operating system. Java is a programming language. So we know the MAC address is an example of what? Example of a data link layer. Okay, this is our analysis for the paper of Andhra Pradesh 2020 Higher Education 2025 paper. I hope this analysis will help you to understand more clearly this subject. Thank you very much.